So hello, welcome back. Uh, welcome back to all the class 9 students. So here we will be studying a new chapter. That is chapter number 10. That is gravitational. In chapter number 9 and chapter number 8. Chapter number 9 and chapter number 8 we have learned about the motions, force, okay, and what is force, what is motions. We have learned that a force in the class 8 or class 7 you have learned that what is a force. A force is a push or a pull. But as we have completed chapter number 9, we have learned the three law of motions, okay. First law of motions, second law of motion, third law of motions, okay. So from there we have learned that, okay, whenever the force is exerted or force is produced if an object have a mass and accelerations. If the object have a mass and accelerations, they exert a force. That we have learned in the previous topic. Okay, so in this topic we will be discussing about the important topic that is called gravitationals. Okay, we will be discussing about the more important topic. The most important topic that is what we call as the gravitationals. Okay, so you might have wonderings, right? If I throw the pens from this marker from here, it fall down, right? Why does it fall? Why does it fall? You might have wondering, right? Whenever you throw up the stones in the height, it reaches to some height and it falls down on the ground again. Okay, so we have always heard about the gravities, okay, the force of the earth, the gravity, the force of the gravity, right? So that is what we will discuss, the details in this topic. That is what we call as a gravitational. Okay, so what is gravitational and how did it come into existence, and who have given these ideas about the gravitational, who are the persons who have started to coin to term this gravitational. That is what we will discuss in this video lectures. Okay, you see, the first ideas was given by the Isaac Newton's. Okay, many scientists have been wondering, right? You have heard that the sun is rotating around, okay, the planet is rotating, okay, revolving around the earth, okay, revolving around the sun. All the planets are revolving around the sun. Similarly, the moon is also revolving around the earth. Okay, there is a question: why this is your sun? Why does the earth only revolve around this? Why does the earth only revolve around this moon? Why does this earth go far away? Why does the earth travel in a straight line? Why they keep on always traveling on a circular path? Okay, so that idea was also, and that was also another ideas. Okay, they were been looking for. They were been in search of it. Okay, so a time was there. It was said in a books, right? It was the first person that is called Sir Isaac Newton. Okay, Sir Isaac Newton. He was the first person who have started this. Okay, you might have wondering, right? Sir Isaac Newton, you have heard about this news. You have heard about his stories. Okay, it's in every books. Okay, one day Sir Isaac Newton was sitting under the tree. Okay, so he was sitting under a tree, and ultimately the apple fall in his head. Okay, then when the apple fall in his head and he wonders, he took out the apples. Okay, he was wondering why this apple does not fall above. Okay, why does the apple does not fall in the sky? Why they fall in the downward? Okay, since if Isaac Newton was a normal person like you and me, we would have just without wondering, would have just eaten up this apple. Am I right? But he was a bit an extraordinary person. Okay, he was an extraordinary person. He want to learn. Okay, the new things. He want to search. He want to do a research on the new things. Okay, and what to let the people know. That is why today we are learning about these gravitationals. Okay, if Isaac Newton, without wondering the apples which fall in his head, if he didn't wonder and he just ate it like you and me, okay, when it fall the apples or whatever it is, you just ate it up, okay, today we would have not learned about the gravitational. We were not given any ideas about the gravitational. It was Sir Isaac Newton who was wondering why this apple was not fall toward the sky, and why this apple was not flying toward the sky, instead they fall down on the earth. Okay, why does it fall on his head? That is what he was wondering. Okay, so in this topic, he was the first person who stirred to learn the force called gravitational force. Okay, you see, a gravitational force is a non-contact force. Okay, is a gravitational force is non-contact force. Okay, gravitational force is one of non-contact force. Okay, and they are one of the weakest force, but their range are so high. Okay, their range is very high. They're one of the weakest force, but their range is very high. Clear about this one? I think you're clear about this one. So when Isaac Newton was wondering, okay, so he was wondering all this about the apples, okay, and then he started in search of it, okay, in search, he keep on going deeper and deeper, okay, and he was wondering why the moon revolves around the earth. Why does the moon does not travel away straight from the earth? Instead, why they keep on revolving around the earth? Why does our planet, okay, our planet revolve around the sun? Okay, why does our planet just move away straight? Okay, so he was wondering about this. So in order to understand this, let us try to understand it. One important example. If I bind the ropes, okay, if I just bind the rope, if I just bind the stone with the rope and start rotating, am I right? Start rotating it. Okay, start rotating it. That what is that? That stone which has been bound with a rope, they keep on revolving round to me, right? Until if I don't release it, okay, that stone will not leave my hand. Instead, they will revolve in a circular path. Okay, so that is what the force, that force is what we call as a centripetal force. Okay, that is what we call about a centripetal force. What is a centripetal force said? A centripetal means what? It is a center seeking force. Okay, it is a center seeking force. Similarly, you see, based on this idea, centripetal force. Okay, based on this centripetal force, our earth, okay, they have an attraction between our earth and the sun have an attraction between each other. Okay, they are attracting, they have attraction between each other, and that force is what the force of attraction between two bodies is what we call as a gravitational. Okay, the force of attraction between two bodies is what we call a gravitational. Okay, similarly, okay, the force is attracting toward the sun is trying to attract the planet toward him. Similarly, the planet is also trying to attract toward the planet. That is what they're trying to seek the centers, and that type of force is what we call as a centripetal force. And what is centripetal force? That is what we call as a center seeking force. Okay, center seeking force. So we'll just make it more understanding. What does it mean? That centripetal force is the force that causes an accelerations. Okay, the forces that cause an accelerations, and the object keep moving on the circulars. Okay, the object keep moving in the circulars is what we call as a centripetal force. Okay, if the force is released by me, like if the rope is released by me, that means what? The stone is going to move on a straight, a tangential to the. If the object is moving, let's say, if I bind the rope from here, and if I bind the rope from here, okay, if I bind the stone from here, let's say this is in a stone, okay, and I'm standing here somewhere here, okay, and if I try to rotate, okay, I mean you're not clear about. Let's try to understand this one first. What does it mean? You see, if I keep this rope binding here, okay, then if I'm standing here, then if I let it to rotate in this direction, okay, they will keep on rotating. Yes or no? So once I release this stone, then this stone will move tangential on a straight line. Okay, stone will move on a tangent. It will leave this direction. it may live in this direction, okay, or it may, if I stop it here in this very point, that means the object, the stone will move in this direction, okay. That means what? Whenever I release the force, okay, in absence of that centripetal force, the object is going to travel on a straight line. Okay, but if the object is circulating, if the object is moving in a circular motion, if the object is moving in a circular motion, such a force is what we call as the force produced due to the force is produced in a circular motions. Okay, the force is produced due to circular motions. Okay, the force is produced due to circular motions. Okay, circular motions circular motions. Okay, the force is produced due to circular motions. Such types of force is what we call as a centripetal force. Center means, you know what is center? Pedal means seeking. Okay, center seeking force. Okay, what is it called? Center seeking force. I think you're clear about centripetal force. Clear? Now you see here, okay, the motions of the centripetal force you have cleared about. The centripetal means what? A center seeking force. Okay, the motions of the moons around Earth is due to centripetal force that is producing by the force that is producing. Okay, centripetal force that is provided. The force is provided by the Earth. Okay, the force is provided. The force of attraction is provided by the Earth. Okay, centripetal force. The Earth, the moon. Okay, which is rotating around in a circular motions. Okay, the motions of the moons around the Earth is due to centripetal force. That the force due to the centripetal force that is produced by the Earth. Okay, the force of attractions. Okay, the force of attraction between the Earth and the moon is taking place. Okay, so this is what they call centripetal force. Clear about this one. Now the thing is that you see, as we are talking about a centripetal force, that is the first case is what? The force of attraction between two objects. Okay, the force of the force of attraction between two objects is what we call as a gravitational force. Okay, the force of attraction between this force will apply the force on this, and this force also will apply the force on this. Okay, so that is what we call as a gravitational force. Okay, now you see, we'll go back to the first point, that is about the apple. Okay, when Isaac Newton was sitting, regarding the Isaac Newton, whenever the apple fall, okay, the apple also exerted the same force on the earth. Okay, apple have also exerted the same force of earth on earth. Okay, in order to make it understand, let's try to understand. You see, whenever you see the moon is attracting the force or not, that is why the moon is not falling towards the earth. Okay, the moon is not falling towards the earth. The earth is attracting the force. That means they're pulling. Okay, they're pulling toward the earth. This earth is trying to pull the moon. Okay, this earth is trying to pull the moon. Correct or not? That means he will try to let the moon to come toward him. Okay, but similarly, similarly the force of the moon is also pulling toward the force of attractions. Okay, the moon is also applying the same force on the earth. Okay, so when the same force are there, the equal force are there, they start repelling and they start rotating around the earth. Okay, so that's what we are discussing about. Okay, similarly you see, now the question is that if every two objects have an attraction, why does the apple also have exerted, whether the apple has also have exerted on the force on the moon, force on the earth? Yes. Okay, the force of the apple have also a mass, and that apple have also attracted the force on the earth. Okay, but their force are very negligible as compared to the earth. Let's take an example. Let's try to go an example. If I try to beat a small kids, right, 2 or 3 years, if I just slap him, that means surely he will cry, right? But if the person he tried to hit me, it will be useless at all. Am I right? It will be useless at all. Why? Because his force is negligible as compared to me. Okay, if I try to pull, the small kids, okay, then I can easily pull to the person towards me. Okay, but that person, the person is also trying to pull towards him, right? The small person, the small kids. Let's say this is a big guy here standing. Okay, this is a big guy here, and this is another small guy. Okay, so these two are having a pull, the force of attraction. This one is pulling toward him, this one is trying to pull toward him, and this one is also trying to pull towards him. Okay, so he is also trying to exert a force on him, but his force becomes negligible as compared to him, right? Because he's a big guy. So that example is taken as when you compare the force of attraction between the force of attraction. Okay, the force between the earth and the apple. Okay, the force between the earth and the apple, force between earth and apples. Okay, this example is taken earth and apples. Okay, the force between the earth and apple. Since the apple is very small as compared to the earth, the force of the apple become negligible in compared with the force of earth. Okay, that means the force of apple become very negligible, become very small as compared to the force of the earth. Okay, so in order to understand this one, you see, if you can understand one thing is that you know that you see Newton's third law. What is that? Okay, Newton's third law. What is it? Newton's third law of motion. Third law of motion. What is it? Third law of motions. What is it? Third law of motion said there will be equal and opposite reaction. So based on this, the earth is also attracting the force on the apple. Similarly, the apple is also attracting the force on the earth. That accepted the third law of motion. But when you come back to the second law of motions, okay, when you come back to the second law of motion, what does the second law of motion say? Okay, the second law of motion said mass is inversely proportional to axis force. Okay, mass is inversely proportional to acceleration. Okay, mass is inversely proportional to acceleration. If the acceleration is very high and their mass will be very less. Okay, if the acceleration is very high, that means the mass will be, their force will be. If the mass of an object is very small, that means the acceleration will be high. That means the mass of the apple is very small as compared to the mass of the earth. That means the acceleration will be less as compared to the acceleration will be more as compared to the earth. That means they can easily fall towards the earth. But you see, the mass of the moons and the earths are somehow, if some like mass of the moons and earths are as compared to, they are considerable. Okay, they are considerable. Okay, the mass of the moons and the mass of the earth are somehow considerable. That is why the moon does not fall toward the earth. But if I throw the stone, if I throw this one, you see, this pen, this cover, a cap is also have some mass. Okay, this mass is also trying to attract the earth. But our earth is so big as compared to this cap, right? As compared to this cap, our earth, the mass of our earth is so big. Okay, that means what? This force, the force applied by this mass become negligible. Okay, that is why that fall toward the earth. Okay, that is what we are talking about. You see, by learning this one, you see whether the mass is very small or whether the mass is very big. Okay, so Newtons have concluded that. Okay, Newtons have concluded that whenever the object have the mass have a very small or the mass is very big. Okay, but in the universe, there is attraction between the two mass. Okay, there is attraction between an object. If the mass are very big or very small, doesn't by assuming whether the mass is very big or small, but there is a force of attraction between the two objects. Okay, there is a force of attraction between the objects, and with that ideas, okay, okay, the Newtons have concluded that, okay, the earth is being attracted by the sun. Okay, similarly, the moon is being attracted by the earth. Okay, so all the universe, whether in the universe, every in the universe, okay, starting from a solar planets, okay, every till in the in our earth, okay, this everything have a force of attractions. Okay, if the object have a mass, okay, and if another object have a mass, that means there will be a force of attraction between them. Okay, so some force may be very negligible, or some force may be very large compared as we compare with the mass of an object. Okay, so here as you see, you can see in the books, you see, but object in the universe attract each others, and this force of attraction between the object is what we call as a gravitational force. So what is it? In the universe, the object attract each other, and that force of attraction between the object is what we call as a gravitational. Okay, what is it? Gravitational. Okay, so that is all about the concepts of the gravitational. Okay, so concept of the gravitational is what in the universe. Okay, in the universe, the object try to attract each other, and the force of attraction between the two objects is what we call as a gravitational force. Okay, so we have learned that what is gravitational. A gravitational is what? It is a force of attraction between two objects. Okay, so let's try to understand the universal law of gravitationals. Okay, so what is the universal law of gravitational say? Okay, the force is directly proportional to the mass of two objects, the product of the masses. Okay, the product of the mass of the two objects, and force is inversely proportional to the squares of the distance. Okay, squares of the distance. Okay, so what is it? You see, if this is an object and this is another object M, let's say this is object M and this is the object M. Okay, that means what? If their mass, the product of these two masses increases. Okay, if the product of the mass increases, that means what? Their force also will increase. Okay, their force also will increase. But if the distance become far and far, if the distance become more, that means that their force will reduce. Okay, if the distance increases, that means what? Their force will reduce. Okay, their force will reduce. Okay, but if the distance is, you see, let's say this is another object, mass m1 and same mass. Their distance, the force, more force will be experienced in here as compared to this one. Why? Because their distance are far as compared to this. Okay, so more distance, less force. Okay, inversely proportional means what? Force will increase. If the distance increase, that means what? The force will reduce. Means if one quantity increases, another quantity will decrease. That is what we call inversely proportional. Okay. But when you talk about a directly proportional, is that if one object is increasing, the another quantity also will increase. That is what we talk about the gravitational law. Okay. So as compared to this, if the two objects, okay, have a mass of these two, then we can equate this one. Then force is equal to inversely proportional mass of an object divided by distance squares. Okay, so what is it? What does it stand? If I say that is what we call F is equal to G into M into divided by D square, where your G is a universal constant. Okay, where is your G is a universal constant. Okay, universal constant. Okay, this universal constant, and the value of this universal constant is 6.673 into 10 to the power minus 11. Okay, 6.673 into 10 to the power minus 11 newtons. Okay, meter squares per kg squares. Okay, Newton meter square per kg square. That is your universal constant. Okay, so this is your universal law of gravitation. What is the universal law of gravitation says? Okay, the force will increase. The force is directly proportional to the mass of the product and inversely proportional to the square of the distance between the two objects. Okay, what is the gravitational law? Universal law of gravitational state. Universal law of gravitational state. Okay, force is directly proportional to the product. Product means multiply of the two mass. Okay, the product of the two mass, and inversely proportional to the distance. Inversely proportional to the square of the distance between the two objects. That means what? If I told you distance, if the object is this two, if the distance between them increases, then the force will increase. Okay. If the distance remains same, but their mass is increasing, that means your force also will increase. The gravitational force also will increase. That is what it says. Okay. So you see, this is a universal. This is a universal. Don't forget this one. The universal gets a universal constant. Okay, universal constant is what? universal constants, gravitational constant, universal gravitational constant. The value of the universal gravitational constant is what? 6.673 into 10 to the power minus 11 Newton meter square per kg square. Okay, so this is your gravitational constant. Okay, so let's try to find out. Let's try to find out again. Okay, let's try to find out the SI unit of, you know that SI unit of force, right? You know the SI unit of force. So SI unit of force is what? SI unit of force is Newton. SI unit of force is Newton. Okay. SI unit of what is it? SI unit of distance. That is D. Okay. Distance is what? Meters. Okay. SI unit of what is it? SI unit of mass. Okay. SI unit of mass is kg. Remember this three. So if you know this three, that means you can easily find out the SI unit of universal gravitational constants. Okay, so let's try to derive the SI unit of gravitational constant. Okay, let's try to derive the gravitational constant. Now you see, we have learned that force is equal to G into M divided by D squares. Okay, so if I want to find out the mass universal constants of G, that means what? F into D squares divided by M, capital M into M is equal to Z. That means what? Z is equal to what? F into D squares divided by M into M. So we know that force is Newton and distance is meter squares divided by kg is mass is kg into kg. That is equal to what? Newton meter squares divided by kg squares. Okay, so this is the SI unit of universal gravitational constant. And universal gravitational, I already told you, their value is what? 6.673 into 10 to the power minus 11 Newton meter square kg. So whenever you got the values of G, whenever you see the G, remember that it is 6.6373. And if you talk about the small g, always remember the small g is 9.8 meter per second. Okay, this is the acceleration due to gravity. Don't get confused with small g and the capital G. Capital G is what? Is the universal gravitational constant. Okay, a small g is what? It is the acceleration due to gravity. The value of acceleration due to gravity is what? 9.8 meter per second squares. But whereas the values of what is it? Universal gas constant is what? 6.673 into 10 to the power minus 11. Okay, so that's all about the video. That is all about today's video lectures. Okay, in the next video lectures, by using these formulas, we'll try to find out some numerical values. By using these formulas, we'll try to find out some numerical problems. Okay, we'll try to find out some numerical problems. Okay, and the last topics of this video lecture is what is the importance of the universal law of gravitationals. Okay, after this next video lectures we will discuss about the numerical problem of this, and this is the last topics on this video lectures. That is what? Importance of the universal law of gravitation. What is the importance of this? Okay, what is the importance of this? The first importance is what? The force of gravitation that led us to bind with the earth. Okay, the force bind us with the earth. Okay, the force that bind us to the earth. The first point is. Second is that the motions of the moon around the earth. If the gravitation is not there, that means the moon will not rotate around the earth, right? Similarly, next is what? The motion of the planet revolves around the sun. If the gravitational is not there, that means what? The planet will not revolve around the moon as planet. The planet will not revolve around the sun. Okay. And second is what? The tide due to the moon and the sun, there will be a tide. So, okay, nowadays we are producing a lot of tide energies. Okay, the tide is between due to the moon and the earth, due to gravitation between the moon and the earth. Okay, so what do we understand? There is a 4 different points. The first point is what? The first point is what? Due to the gravitational, we are being bound with the earth. Okay, if the gravitation is not present, that means we will be flying here and there, right? Second is what? Due to the moons, due to the gravitational force, okay, the moon is revolving around the earth without any problems, right? Third is what? All the planets are revolving around the Earth. Okay. Next is what? Okay. There is a tide energy due to the moon and the Earth. So that is all about the video lecture, the importance. Okay, we have learned about the gravitational. What is gravitational? Second, universal law of gravitational. Next, we have learned what is the importance of gravitational. Next, in the next video lectures, we'll first solve the numerical problem based on this question, and then we'll discuss about the free fall. Okay, and free fall. Okay, so that's all for video lectures. Go through the textbook, studies, and make a notes of yourself. Okay, thank you. Bye bye.